the greatest unsolved mysteries of science and nature. Throughout human history, the pursuit of knowledge has driven scientific discoveries and unraveled many of nature's secrets. From decoding the laws of physics to exploring the microscopic world of atoms and cells, science has illuminated much of the universe's mysteries. However, despite our remarkable advancements, there remain questions that defy explanation, enigmas that continue to puzzle scientists, researchers, and thinkers alike. These unsolved mysteries span the vastness of space, the depths of our oceans, and even the workings of our own minds. They challenge our understanding of existence, the origins of life, and the limits of human perception. Why does most of the universe remain invisible? How did life first appear on Earth? What lies beneath the unexplored ocean floor? In this video, we delve into the top 10 unsolved scientific and natural mysteries that remain beyond our grasp. Each mystery is a reminder of the universe's complexity and a testament to humanity's relentless curiosity to seek answers. 1. The origin of the universe. The origin of the universe remains one of the greatest mysteries in science. The widely accepted Big Bang theory suggests that the universe began approximately 13.8 billion years ago from a single, infinitely dense point known as a singularity, which rapidly expanded to form the cosmos we observe today. However, this explanation raises deeper questions. What caused the Big Bang, and what existed before it? Despite significant advancements in cosmology and physics, scientists are still unable to fully explain what triggered this monumental event or the true nature of the singularity itself. Some theories, like the cyclic model or the multiverse hypothesis, propose that the universe is one of many or part of an eternal cycle of expansions and contractions. Yet, evidence remains elusive. The limitations of current technology and our understanding of physics near singularities create barriers to uncovering the full truth. 2. The nature of dark matter and dark energy. Dark matter and dark energy are among the most perplexing phenomena in modern astrophysics. While the universe is composed of ordinary matter, stars, planets, and galaxies, this visible material accounts for only about 5% of the total universe. The remaining 95% consists of mysterious entities: dark matter, 27%, and dark energy, 68%. Dark matter is thought to be an invisible substance that does not emit, absorb, or reflect light, yet it exerts gravitational effects, holding galaxies together and influencing their rotation. Despite its critical role, dark matter has never been directly observed, and its exact nature remains unknown. Dark energy, on the other hand, is believed to be responsible for the accelerating expansion of the universe. First observed through distant supernovae in the 1990s, this repulsive force acts in opposition to gravity, pushing galaxies further apart. Scientists speculate that dark energy might be linked to the cosmological constant, a concept introduced by Albert Einstein, or perhaps a yet-to-be-understood quantum field. However, its origin and mechanism are still theoretical. The search for dark matter and dark energy continues through advanced experiments, like those conducted using the Large Hadron Collider, LHC, and space observatories such as the James Webb Space Telescope. Yet, the absence of concrete evidence leaves scientists grappling with one of the greatest challenges in cosmology: understanding the invisible forces and substances that shape the universe. 3. The origin of life on Earth. The origin of life on Earth is a profound mystery that continues to intrigue scientists. How did non-living chemical elements evolve into the complex, self-replicating systems that gave rise to life as we know it? One of the leading theories is abiogenesis, which proposes that life began from simple organic molecules formed under early Earth's harsh conditions. Experiments, such as the famous Miller-Urey experiment in 1953, demonstrated that amino acids, the building blocks of proteins, could arise from inorganic materials when exposed to energy sources like lightning. However, this theory does not fully explain how these molecules assembled into the first living cells. Another hypothesis, panspermia, suggests that life originated elsewhere in the universe and was transported to Earth via meteorites or comets. Evidence of amino acids and complex organic molecules found on space objects supports the idea that the ingredients for life might be widespread in the cosmos. Despite advances in biology, chemistry, and astrobiology, the transition from simple molecules to self-replicating life forms, such as RNA or DNA, remains unclear. Scientists continue to explore hydrothermal vents in the ocean, icy moons like Europa, and the surface of Mars for clues about life's beginnings. Understanding the origin of life could unlock not only our past, but also the potential for life elsewhere in the universe. 4. The Fermi Paradox. Are we alone in the universe? The Fermi Paradox highlights a striking contradiction. Given the vast number of stars and planets in the universe, it seems highly probable that intelligent extraterrestrial civilizations exist. Yet, despite decades of searching, no conclusive evidence of alien life has been found. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" The paradox raises profound questions about the nature of life and our place in the cosmos. There are billions of stars in the Milky Way alone, many with planets in the habitable zone, regions where conditions might support life. If advanced civilizations have developed elsewhere, their technological advancements could have allowed them to explore or communicate across the galaxy. Yet, we see no signs, no alien signals, spacecraft, or artifacts. Several explanations have been proposed. One possibility is the Great Filter, a theoretical barrier that prevents life from progressing beyond a certain stage. Either life itself is rare, or advanced civilizations destroy themselves before achieving interstellar travel. Other theories suggest aliens may be deliberately avoiding contact, are too far away, or use communication methods we cannot detect. The search for extraterrestrial intelligence, SETI, and missions like James Webb Space Telescope aim to find answers by scanning distant planets and signals for signs of life. Until then, the Fermi Paradox remains one of science's greatest unsolved mysteries, challenging us to consider whether humanity is truly alone in the universe. 5. The mystery of consciousness. Consciousness, the state of being aware of oneself and the environment, remains one of the greatest mysteries in science and philosophy. While we understand many processes of the brain, the question of how and why physical processes give rise to subjective experiences, such as emotions, thoughts, and sensations, remains unanswered. This is often referred to as the hard problem of consciousness, a term coined by philosopher David Chalmers. From a scientific perspective, consciousness arises from the complex neural activity of the brain. Techniques like fMRI and EEG allow scientists to study brain functions and identify regions linked to decision-making, emotions, and perception. However, these methods only reveal correlations between brain activity and experiences. They do not explain how subjective awareness emerges from physical matter. Theories attempting to explain consciousness range from integrated information theory, IIT, which links consciousness to information integration in the brain, to global workspace theory, GWT, suggesting that consciousness involves the brain broadcasting information to multiple neural networks. Yet, no theory fully resolves the mystery of subjective experience, what philosophers call qualia, such as the redness of red or the pain of a headache. Understanding consciousness is not just a philosophical pursuit. It has practical implications for artificial intelligence, neuroscience, and medicine. As scientists explore deeper questions about the brain and its connection to the mind, the nature of consciousness remains elusive, challenging our understanding of ourselves and the very essence of existence. 6. The Bermuda Triangle. The Bermuda Triangle, also known as the Devil's Triangle, is a loosely defined area in the western Atlantic Ocean, where ships, airplanes, and crews have reportedly disappeared under mysterious circumstances. The region forms a triangular boundary between Miami, Bermuda, and Puerto Rico. Since the early 20th century, stories of vanishing vessels and aircraft have fueled speculation and conspiracy theories, making it one of the world's most enduring mysteries. While some attribute these disappearances to natural explanations, such as sudden violent storms, powerful ocean currents, or magnetic anomalies disrupting navigation systems, others speculate about more extraordinary causes like extraterrestrial activity, underwater alien bases, or time warps. Some theories also point to methane gas eruptions from the ocean floor, which could theoretically reduce water density, sinking ships instantly. Despite its reputation, many scientists and maritime experts argue that the Bermuda Triangle is no more dangerous than any other heavily trafficked region of the ocean. Modern investigations reveal that many incidents can be explained by human error, equipment failures, or harsh weather conditions. Additionally, improved satellite tracking and technology have reduced the number of unexplained cases in recent decades. Still, the Bermuda Triangle continues to captivate imaginations worldwide. Whether a product of myth, coincidence, or an undiscovered natural phenomenon, this mysterious stretch of ocean remains a source of fascination and speculation, keeping its legend alive. 7. What lies in the deep ocean? The deep ocean, which covers more than 80% of Earth's surface, remains one of the least explored and most mysterious places on our planet. Despite advances in technology, over 80% of the ocean floor remains unmapped, unobserved, and unexplored. The extreme conditions of the deep sea, such as crushing pressures, complete darkness, and freezing temperatures, make it a challenging environment for human exploration. Yet, this vast, hidden world is believed to hold answers to questions about Earth's history, unknown ecosystems, and even potential medical and technological breakthroughs. The Midnight Zone, located thousands of meters below the surface, is home to bioluminescent creatures that produce their own light to survive in the pitch-black environment. Deep-sea expeditions have uncovered bizarre species like the anglerfish, giant squid, and vampire squid, creatures that have adapted in ways we still don't fully understand. Hydrothermal vents, discovered only in the late 20th century, support entire ecosystems powered by chemosynthesis instead of sunlight, challenging traditional notions of life. Furthermore, the deep ocean holds immense geological mysteries, including submarine volcanoes, underwater mountain ranges, and vast trenches like the Mariana Trench, the deepest known point on Earth. Scientists also believe the ocean floor may conceal valuable resources, such as rare metals and minerals, as well as clues to Earth's climate history locked within sediment layers. As technology advances with tools like autonomous submersibles and sonar mapping, we are beginning to uncover this alien-like world. Yet, much of the deep ocean remains uncharted, leaving us to wonder what extraordinary life forms, geological wonders, or even new ecosystems might await discovery in Earth's final frontier. 8. The mystery of antimatter. Antimatter remains one of the most intriguing and perplexing mysteries in physics. In theory, antimatter is the mirror opposite of ordinary matter. Each particle of matter, like protons and electrons, has a corresponding antiparticle with the same mass but opposite charge. When matter and antimatter meet, they annihilate each other in a burst of pure energy. Scientists believe that antimatter should have been created in equal amounts with matter during the Big Bang, yet the observable universe consists almost entirely of matter. This imbalance is one of the greatest unsolved questions in cosmology. Where did all the antimatter go? The phenomenon of antimatter was first predicted by physicist Paul Dirac in 1928, and its existence was later confirmed with the discovery of the positron, the antimatter equivalent of the electron. Today, antimatter can be produced in small quantities in particle accelerators, such as the Large Hadron Collider, LHC, where high-energy collisions mimic conditions shortly after the Big Bang. However, creating and containing antimatter is extremely difficult due to its tendency to annihilate upon contact with matter. The disappearance of antimatter could hold the key to understanding the fundamental forces of the universe. One theory suggests that a subtle difference between matter and antimatter, known as CP violation, may explain why matter dominates the universe. Another possibility is that antimatter exists in distant regions of the cosmos, forming antimatter galaxies we have yet to detect. Solving the mystery of antimatter is not only vital to understanding the origins of the universe, but also has practical implications. In the future, antimatter could revolutionize energy production and space exploration, as its annihilation releases enormous amounts of energy. Until then, the nature and fate of antimatter remain one of science's most fascinating puzzles. 9. The Taos Hum. The Taos hum is a mysterious low-frequency sound reported by residents of Taos, New Mexico, and various other locations worldwide. Described as a faint, persistent buzzing, droning, or humming noise, it is often heard in quiet environments, primarily during nighttime. While some individuals are highly disturbed by the sound, others cannot hear it at all, adding to its mystique. The hum has puzzled scientists, acoustics experts, and engineers for decades, as its exact source remains unknown. Theories attempting to explain the Taos hum are numerous. Some suggest that it could be caused by industrial equipment, such as power lines, pipelines, or machinery emitting low-frequency vibrations. Others propose natural causes, such as seismic activity, tectonic plate movements, or wind interacting with the landscape. More speculative explanations include auditory hallucinations, electromagnetic interference, or even secret government projects. Studies, including one commissioned by the University of New Mexico in the 1990s, found no definitive source for the hum, despite analyzing sound levels and vibrations in the area. Scientists note that individuals sensitive to low-frequency noises may experience the hum as a result of enhanced hearing or specific physical conditions, such as tinnitus. The Taos hum remains an unsolved acoustic phenomenon, sparking curiosity and frustration in equal measure. Whether it has a mundane explanation or points to an undiscovered natural or technological cause, the hum continues to confound researchers and fuel both scientific inquiry and local legends. 10. The placebo effect. The placebo effect is a fascinating and still poorly understood phenomenon where a person experiences real physical or psychological improvements after receiving a treatment that has no active therapeutic ingredient. For example, a patient given a sugar pill or saline injection, believing it to be real medicine, can report reduced pain, improved mood, or even recovery from symptoms. This effect highlights the power of belief and expectation in shaping health outcomes, but the underlying mechanisms remain a mystery. At its core, the placebo effect demonstrates the mind's profound influence on the body. Researchers suggest that the brain can trigger physiological changes, such as releasing endorphins, natural painkillers, or altering hormone levels in response to the belief in treatment. Placebos have been shown to activate the same brain pathways as actual medical treatments, indicating a complex interaction between the brain, nervous system, and immune response. The placebo effect raises critical questions. Why does belief cause measurable physical changes? Why does it work for some individuals and not others? Studies also show that the placebo effect can occur even when patients are aware they are receiving a placebo, further deepening the mystery. Beyond its scientific implications, the placebo effect challenges our understanding of medicine and the doctor-patient relationship. It also complicates clinical trials, where placebos are used as controls to measure the effectiveness of new drugs. While the placebo effect continues to baffle researchers, it offers promising insights into the brain's role in healing and highlights the power of perception, trust, and the mind-body connection. The mysteries explored in this article remind us of the vast and complex nature of the world and universe we inhabit. From the enigmatic origins of life and the universe, to the unexplored depths of the ocean and the puzzling workings of our own minds, these unsolved questions challenge the limits of human understanding. They not only highlight what we do not yet know, but also inspire curiosity, innovation, and the relentless pursuit of answers. As science and technology continue to advance, we may one day uncover the solutions to these mysteries. Yet, each discovery often opens the door to new questions, keeping the cycle of exploration alive. These unresolved phenomena serve as a powerful reminder of the beauty of the unknown and humanity's unyielding drive to seek, learn, and explore. The journey to solve these mysteries may be long, but it is through this quest that we continue to grow as a species, unlocking secrets that shape our future and deepen our understanding of existence itself.